Well, guys, just want to go through the worksheet, review worksheet to make sure you're good with it. So one thing that we want to look at is we have 4 tests. So we have a large sample, okay, test the mean, and a small sample, test the mean. So we're looking at large sample, small sample. So I have a sample 47 and I have a sample 53. So then the other 2 tests, we have a test of proportion and then dependent sample. And then dependent test the mean. So this is like, dependent is like a pre-test / post-test. Okay, proportion, we're looking for percent. Okay, in these, they give me the sample size, they give me the mean, and they give me the standard deviation. So standard deviation, they give me sample size, mean, standard deviation. So this right here is a large sample test of mean. So we're going to go ahead and write it. So we want to test the null hypothesis to see that there's a difference between the 2 populations. So I'm just going to say, hey, does population 1 equal population 2? Which is, if you look at it, it's this idea that, okay, a separate group rates the risk of the same people but not smiling, produce a mean of this and this. So in other words, we want to rule out the possibility that the idea is, does smiling, having this picture, help in the death rate? And so that's what we're looking at. So alternative is that they're not equal to. Our alpha value is 0.05, so we're going to divide that by 2. So we go to our table. Okay, we go down here. It's a large sample, so it's right here. Okay, alpha value, divided by 2, so it's over 1, so it's right here. So we're looking at our alpha value 1.96. So we have this alpha 1.96. So then we got to do our equation. Our equation, just to point out, large sample is right here. So we're using this one. Difference of the 2 means. So this is the mean and the mean, or the average. This is the standard deviation 1 squared, standard deviation 2 squared. This is our sample size. Okay, N1 and N2, those are our sample sizes. So here, so we'll go back, we'll do it real quick. So we come here and we subtract these 2. So we're going to go through 2 minus 3 divided by the square root of standard deviation is 1.5 squared over 47 plus 1.75 squared over 53. So from there, we go ahead and do that on our calculator. So we go 2 minus 3 equals, divided by the square root of 1.5 squared, 1.5 squared, divided by 47, plus 1.75 squared, divided by 53. And you could just put that all in parentheses and hit enter, and we get negative 3.07. Negative, so this all equals negative 3.08. We compare this value to this value. Since this one's negative, we'll make this one negative. Since that's to the left of it, we would reject. And so we want to know, is there a difference between the 2 populations? Yes. So we'd say, okay, evidence suggests there is a difference in the 2 populations. If you go to the next one, we have sample size of 20 and of 27. So we're going to have to go ahead, and this is a small sample. We want to perform a hypothesis test to test whether the evidence that the mean post-test scores for women is higher than men. So I could say my null is that the women, we assume the opposite. We want to test to see if it's higher, so we're going to say is less than or equal to the mean. And our alternative is that the woman is greater than the mean. Okay, this is a sample size, so we're going to add these 2 for degrees of freedom. 20 plus 27 minus 2, so that would be 45. So we go to our chart, 45 and an alpha value of 0.10. So we go to our table, 45, there's nothing in between, so we'll go to 50, and then 0.10, which is the second column. So it's 1.299. So we're going to write that in there. So that's our alpha value, give us a t-score 1.299. So now we have to find the pooled variance. So we go the equation. So again, if I look at it, just going to point out to you the equations I'm going to use. There we go. So first one I'm going to use is this pooled variance right here. Then once I pool the variance, then I'm going to plug it into this equation, which is just like the large sample. So we're going to start there. The pooled variance. Okay, so we do our sample size. So 20 minus 1 times the standard deviation, which is 8.99 squared, plus sample size 27 minus 1 times our standard deviation squared, 9.27 squared, divided by our two sample sizes added together, minus 2. Now, when I plug this in, I got to put this whole top in parentheses and this whole bottom in parentheses as I get to it. I'm going to simplify some of it too. So I'm going to take the square root. 20 minus 1 is 19 times 8 point. Actually, I want to go back. I'm going to put this in. So it's 20 minus 1, so that's 19 times 8.99 standard deviation squared, plus 26, 9.27. So 26 plus, or times 9.27 squared, 27 squared. So that's the top, divided by those two, 20 plus 27 minus 2, which is 45. And so that gives me a pooled variance of 9.51. So this is 9.51. So now I plug it in. So I'm going to subtract it. These two are my means here. These are my standard deviations here. So I go ahead, 85.15 minus 83.74 divided by the square root of the pooled variance, 9.15 squared over 20 plus 9.15 over 27 squared. And so now, oh, not 20, this one is squared, not down low. So we're not squaring the sample size. So we're going to go ahead and do that, 85.15. So 85.15 minus 83.74. 83.74 equals, divided by the square root of 9.15 squared divided by 20 plus 9.15 squared divided by 27. And that all equals 0.52. So equals 0.52. So we do not reject. So is there a significant difference? Do the women score significantly higher? We'd say no. There is not evidence the women's score significantly higher. Okay. So then we go on to this one. This one, if you look at, is a pre-test and a post-test. It actually says here, pre-test, post-test. Okay, patient 1 takes a pre-test. So the same patient takes the pre-test and the post-test. So if you go for it, okay, you would subtract these values. So you go this minus this, make a Google Sheet. And if you look at, we're subtracting all these values. And I have made a Google Sheet. And this is what it looks like. So we subtracted all these values. So 208 minus 22 gave us 186. So the average, so we subtracted all these. The average difference was 195.8. and the standard deviation was 76. So the average difference was 195.8, and the standard deviation was 76. So, okay, is there evidence that the treatment has reduced the number of anyways, so has reduced it. So we want to know, has the pre-test reduced it? So we're going to say if it's reduced, that means the second one is smaller. So we're going to say that the pre is less than or equal to than the post. And our alternative is that the pre is greater than the post. Okay, so then we have our alpha value, 0.05. So we're going to do 9 minus 1, so degrees of freedom. For this one is 9 minus 1. So we're going to look up 0.05 and 8 on our table. So 0.05 and 8 right here, and we get 1.86. So we have our alpha value is 1.86. Okay, and now we go ahead and do our test. Again, I'll show you our test. So we're using this one, the average difference of the average of all the differences, which is what we found, the standard deviation of the differences, which we found, and our sample size. So we're going to come through here and do 195.8 divided by the standard deviation divided by the square root of 9. And so we plug that into our calculator. 195.8 divided by 76. So I do need to put that parenthesis in the bottom. 76 divided by the square root of n. It equals, and we get 7.7. So this is 7.7. So we would reject. So, is there evidence that the treatment has reduced the number? Yes, there is evidence that reduces it. Again, I'm not writing it down. You do need to write it down. I'm trying to shorten it up a little bit. So last one, here you go, population proportion. So that means it's a test of proportion. So when we go to the test of proportion, just let me highlight it. First things we got to do. There we go, test of proportion. So we got to pull the variance right here and then plug it in as we go forward from there. So we will do that right now. We will pull our variance. So it's 15 plus 18 divided by 35 plus 35. So that's out of 70. We have 33 out of 70, which is equal to 33 out of 70 is 0.47. So that's 0.47. So that's a pool variance. I already found the proportions. So for this one, I went 15 divided by 35, and that gave me 43%. I went 18 divided by 35, and that gave me 51%. So just to point out where I got those. We want to... Okay, after seeing the results on the test, the company decided that it really wants to know whether the higher proportion of women than men use email. So higher proportion, so we want to see if the women are higher. So we're going to assume the less and say they're less than the men. And then our alternative is that our women are greater than men. All right, they don't give us an alpha value. So if they don't give you an alpha value, it's 0.05. And so we go to our chart. This is a large sample. So we go to our chart, 0.05 down to the end. So that's 1.645. All right, there we go. Just got to go back. So 1.645 is what I'm working with. And now we're going to go ahead and write the equation. So it's proportion 1 minus proportion 2 divided by the square root of our pooled proportion, which is 0.47, then 1 minus that pooled proportion, and then 1 over our sample size 1 plus 1 over our sample size 2. So we're going to go ahead and do that. Okay, so 0.43 minus 0.51 equals divided by the square root of our pooled proportion, which is 0.47 times 1 minus 0.47, and then times, and you don't have to put times, 1 over sample size 1 plus 1 over sample size 2. And so there we go. We hit equals, and we get 0.65. So I just want to make sure I did it right. I'm going to double check this one. So it was negative point. Clear, it was negative. Wow, just 0.08. So, wow, I'll start 0.43 minus 0.51. Okay. Divided by the square root of 0.47 times 0.53 times the square root, or not the square root, times 1 divided by sample size 1 plus 1 divided by sample size 2. There we go. Okay, so yeah, 0.67. So equals negative 0.67. So again, I compare this value to this value here. Do not reject. To go through. So again, is there show that women have a higher proportion? No. We're seeing there's essentially there's not a significant difference between these two ones as you work through it. So that's how we go through the worksheet. These are the type of questions. So you just need to be looking: is it a proportion? Is it pre-test, post-test, large sample, small sample?